The simplest numerical integration method to find an area of a given function is midpoint rule. Check this example here in numerical solutions to see problems. We are to determine the area under the function 2.5x with the root of x squared plus 2 from the boundaries of 2 to 4.4. It is instructed that we are to create 6 differential strips. Even without drawing the function, we can solve for the area by first graphing the limits from 2 to 4.4. With the x distance already identified, work on the 6 rectangles by dividing the distance by 6, making the sub-coordinates 2.4, 2.8, 3.2, 3.6, and 4. Also, we are able to find the width of each rectangle as 0.4. We tag this as delta x. The next step is then to take the midpoint of each span. The concept behind the midpoint is like taking the average height from the width. Then solve for the individual areas. The first strip has x sub 1 as 2.2, its midpoint. Taking into consideration that the area of a rectangle is height by width, we solve it as y times delta x. But then, what is y? Y is computed from the equation 2.5 times x with the root of x squared plus 2, where we plug x of 2.2. The area of the first rectangular strip is 33 root of 19 upon 25. The second rectangular area is computed similarly. Take the midpoint of the second span from 2.4 to 2.8, and that is 2.6. Use this value as x into the function, then multiply it by delta x, which is 0.4. That is 2.5 of x, which is 2.6, times the root of x squared, which is 2.6 squared, then add 2. Then multiply delta x of 0.4. The second area comes out as 13 root of 219 upon 25. For the third strip, the midpoint is half of the summation of 2.8 and 3.2, which is 3. The area then is y, which is 2.5 times 3, with the root of 3 squared plus 2, multiplied by delta x, which is 0.4. The third area is then simplified as 3 root of 11. The fourth strip uses the midpoint of 3.4, taken from half the summation of 3.2 and 3.6. Use this value as x in the function, making it 2.5 times 3.4 with the root of 3.4 squared plus 2. Then multiply the function by 0.4, resulting to 17 root of 339 all over 25. Take the fifth strip using similar setup. The midpoint value of x for the span is 3.8. So the fifth area is 2.5 times 3.8 times the root of 3.8 squared plus 2, then multiply 0.4. The fifth area is 19 root of 411 all over 25. For the last strip, the midpoint x is taken as the value between 4 and 4.4, and that is 4.2. Plug these into the function to have 2.5 by 4.2 with the root of 4.2 squared plus 2. Then multiply it by 0.4. A sub 6 then comes as 21 root of 491 divided by 25. Now let's summarize what we have solved so far. A1 is 33 root of 19 upon 25. A2 is 13 root of 219 all over 25. The third area is 3 root of 11. And the fourth is 17 root of 339 over 25. A5 is 19 root of 411 upon 25, while the sixth was solved as 21 root of 491 all over 25. Add all these areas and have the total area for the curve bound from 2 to 4.4 as 69.93979.